and the shell method. Now remember in the disk method, we would have f of x. This is the disk method here. When it has that hole in it, some people call it the washer method. I just call it all the disk method. But if we have f of x here and we're rotating around the x-axis, we are working with dx in terms of x is the disk method, and we use pi r squared. So we take this and we rotate it around the axis. The problem is, consider a graph that looks like this. This is a very specific graph. And it says y equals 2x squared minus x to the third. And the problem says to rotate it around a y. Now, if this was the disk method, this is not, so I'm going to write it in green. But if this was the disk method, we would need it to be in terms of y, and we'd say pi r squared. But you cannot solve this equation of y equals in terms of y. It doesn't happen. So the disk method is not going to work. We're going to use the shell method. And in the shell method, we're going to be in terms of the other variable. So when we go around y or parallel to y, we're going to be in terms of x. And this is going to be the shell method. And our formula is going to be 2 pi rh. Now I'd like for all of that to be on the left side of the equation, but we're going to come back and do this. So what happens is in the disk method, we take a disk like this and we rotate it around the axis, and it gives us a disk. Remember that disk look? And in this disk, we can say that the radius is perpendicular to our axis of rotation. Now, that's still going to be true. Your radius is going to be perpendicular to your axis of rotation. So this is going to be my radius. And then this is going to be my height. And we're going to focus on that in a little bit, but not right now. And we're going to take and rotate this around the axis, and it gives us a shell. The best way to describe the shell is we have some little width here. So if you think about a can, this is like the can of green beans. So if we were to cut that shell somewhere and lay it flat, we have like the label on a can of green beans or any kind of food. So right here we have 2 pi r, and here we have the height h. So if we were to cut that shell and lay it out, you could see it. Let me show you a couple of what these look like. So here you can see three pictures of cylindrical shells. This first one shows you it's a cylindrical shell. It is not a right circular cylinder. It is not solid. What what we see is we're taking this piece, this red piece right here, and we're rotating it around the axis, and it forms that shell. Kind of, it's a little thicker, but kind of like the label on a can. I like to talk about a can of green beans because I like green beans. But if we were to lay this label out, it would be 2 pi r, and then we have the height. So that's what gives us our volume as we rotate it around the axis, and we're going to work with that 2 pi rh. So the volume of this is the 2 pi rh times however thick this red piece is. I'm drawing on it, but you can't see it. However thick this red piece is. So then we're going to put a delta x here, and you're going to see that that's how we get our integral is d of x. So you can see that the smaller we make our shell pieces, the smaller we make this little rectangle, the better our approximation is. Here we have a little rectangle here, and over here we have the same rectangle, and then up here it's a slightly different rectangle, but it's still rotating around the y-axis. But the advantage of the shell method is it allows us to be in terms of the other variable. And there are times that has to happen, but there are times where it can happen. The volume of the solid in a figure obtained by rotating about the y-axis, the region under the curve, y equals f of x from a to b, is the volume equal the integral from a to b, 2 pi x f of x dx, where 0 is between a and b. So you can see how that correlates to the formula we used up above. Volume equals 2 pi rh, and then our h is going to actually be f of x. You can see it in the figure up here that the height of that figure is f of x. We're going to spend a lot of time talking about that, but a note I want you to make is that your r is still perpendicular to the axis of rotation. But the difference between the disk and the shell is in the shell method, we're going to be in terms of the other variable. So the other variable. So when we're rotating around the y-axis, we're going to need to be in terms of x. That's going to help us do that problem we looked at initially. So let's look at that. So let's write this down and make some notes. The volume, this is for the shell method. I like both, but I like the shell method. I get tired of squaring things in the disk method. So the shell method says the integral from a to b 2 pi r h dr. The 2 pi r h is how you find that cylindrical shell, and the dr is the width of that. So there are some important notes we want to make. First of all, r is going to be x or y. Later, not right away, r is going to be x or y plus or minus an outside line. Okay, so that's a change we're going to make later. Right now it is x or y. Let's talk about this figure right here. Let's go back to this one. Our radius is going to be perpendicular to the line of rotation. So we're going to draw our radius to be perpendicular to this line, and it stops somewhere in here. So this is our radius. Now remember, this is y in terms of x. So we have a f of x here, and I'm not going to worry about that because I'm just talking generally. Now, if my r stops here, this is my h1, and it has this height, and my length is whatever x sub 1 is. Now, if my r stops a little farther over here, now my height is h2, and this is x2, but this is still an x value. And as we move over, let's say we're over here, we have x sub 5. This is h sub 5. It's our height. Now notice our height is always equal to the y value. So our height is going to be equal to the y value, and r is going to be equal to x in this case. And it's the random x that is all the values covering the integral from a to b. So that's why our radius is always going to be equal to the letter x or the letter y, no more or no less until we bring in an outside line for our rotation, okay? Our height is going to be equal to f of x or f of y, depending upon which one we're working in. The other big change here is we're in terms of the other variable. So if we're going of the other variable, couldn't remember what to write. So if we're going around the x-axis, we're going to be in terms of y. X-axis or parallel to the x-axis, we're going to be in terms of y. And if we're going around the y-axis or parallel to the y-axis, we're going to be in terms of x. So what this means, I think I can scooch this in just a little bit. So what this means is if we're going around the x-axis, then we're going to say that we're going to be in terms of y. So we're going to say the integral from a to b, 2 pi, our radius is y, and then we have a function in terms of y with respect to y. And if we're going around the y-axis or parallel to the y-axis, we're going to say the volume from a to b, 2 pi x. We're going to be in terms of x dx. So that's your big concepts for your shell method. So let's look at that beginning problem we talked about. So that beginning problem we talked about looks kind of like this. It tells us it goes through 0 and 2, and that y equals 2x squared minus x to the third. And we have the area under the curve here. I'm going to sketch a little bit of it in so you can kind of see it there. Now, we're told that we're going around the y-axis, so we cannot use the disk method because all of this is in terms of x and you cannot solve for y. So we know we need to switch methods. We're going to use the shell method here because I want to be in terms of x and I'm going around y. And I'm going to use the formula 2 pi RH. So I'm going to draw a line that doesn't show up very well. Let's try a different color. I'm going to draw a line right here. This is perpendicular to the axis. Your height is perpendicular to the axis, and then your radius still goes around the line of rotation. So this is my radius, and the other one has to be my height. Now the radius is easy right now because it is the letter x or the letter y. We are in terms of x over here in our function, therefore r is going to be x, and h is going to be the function 2x squared minus x to the third. So we're going to say volume equals the integral from a to b of 2 pi rh dr. Now I'm in terms of x, this dx over here on the far left, it reminds me of that. So my x bounds are 0 to 2. 2 pi, my radius is x or y, so in this case it's x because I'm in terms of x. My h then is 2x squared minus x to the third, and I have a dx at the end because we are working in terms of x. So I need you to pause and think about this here. This is the big thing we're picking up is the difference between disk and shell and how to use them appropriately. And we're going to do quite a few of them. So let's keep going with this. And we have v equals, let's pull that 2 pi out front. I like it out front. The integral from 0 to 2. Now, the reason we're rewriting this is we have to use the distributive property. So we have 2x to the third minus x to the fourth with respect to x. You cannot integrate the above line. It doesn't work. So now we have 2 pi, and when we integrate, x to the third becomes x to the fourth, and 2 over 4 is 1/2, minus x to the fourth becomes x to the fifth, so we have 1/5 x to the fifth from 0 to 2. So I have 2 pi, 2 to the fourth is 16, and half of that is 8, minus 2 to the fifth is 32 over 5, minus 0 plus 0. Always check that those zeros really are zeros. So I get 2 pi, and 8 is 40 over 5, minus 32 over 5 is 8 over 5, times 2 pi gives me 16 pi over 5. Final answer, done. Yay! So I want to show you what the shell look like and what the 3D figure looks like. So this is one of the shells rotating around, and you can see that it has the radius of x and the height is the f of x. And here we have a computer generated version of what this looks like when you rotate it around the y-axis from the top, apparently. All right, let's do another one. This graph looks very similar to the last one, but it says it starts here and it goes like this, and it says y equals sine of x squared. The problem also gives us the bound here to be the square root of pi, and our shaded area is the area underneath this curve. And the problem also states that we are rotating about the y-axis. Wrong writing utensil, let me try it again. We're rotating about the y-axis. So I think that's everything we need for the problem. It says set up but do not integrate. So let's play that game. Set up but do not integrate. So what we're going to do is when we look at y equals sine x squared, I do not want to solve that for x equals. So I want to work in terms of x. I want to work in terms of x and use that equation sine x squared, but I'm rotating around the y. So in order to work in terms of x, we have to call this the shell method and use 2 pi rh. So we're going to draw our radius line from our axis of rotation into the middle somewhere. So r equals x. R equals x because we're in terms of x. If we're in terms of y, r would equal y until we go around an outside line, and I promise we're going to get it to that. So then we have this line here, h equals, and our height is the function sine of x squared. So now we can say the volume is the integral from a to b of 2 pi rh dr. So we're going to say this is the integral from 0 to the square root of pi. And we have 2 pi. Our radius is x, and our h is sine of x squared with respect to x. I don't see any reason to not do this problem, so we're going to keep going. So when we do this, the problem is that we have an x squared here, and you can't integrate x squared. So let's let u equal x squared, and then du is going to be 2x dx. So dx is 1 over 2x du. And we need to talk about bounds. So we're switching from x to u. Our top bound is the square root of pi, and our bottom bound is 0. So when x is the square root of pi, u is the square root of pi squared, which is pi, and 0 stays 0. So now we have the integral from 0 to pi, 2 pi x sine of u times 1 over 2x du. Now these x's cancel nicely. Yay, because if they didn't, we'd have a problem. And I'm going to pull my 2 pi out, the integral from 0 to pi, sine of u du. So we're going to bring down the 2 pi. When we integrate the sine of u, we get negative cosine of u. I'm going to put that negative out front. Negative cosine of u from 0 to pi. So we're going to say negative 2 pi times cosine of pi plus 2 pi cosine of 0. The cosine of pi, you have to think about what that graph looks like, or think about your unit circle. So I have negative 2 pi, and the cosine of pi is negative 1. And I have plus 2 pi, and the cosine of 0 is positive 1. So I end up with 2 pi plus 2 pi, which equals 4 pi. You shouldn't get an area of 0. You shouldn't get a volume of 0 either. So when your area and your volume equals 0, you should, if they ever do, then you should go check your answer because something went wrong. Now, the next thing I want to tell you about, so there are two steps to this. The first one is sometimes you have two functions. So let's start off with y equals x squared. This is a classic problem that you're going to see in lots of ways. You've already seen it with area under the curve and the other volume. And y equals x. I like two different colors. And let's rotate this around the x-axis so that we can do it differently than we've done the others. Now here's the change. Here you have two functions. You have a function here and a function here. That's going to affect your height. So we're going to take and we're going to be around the x-axis. That means we're going to be in terms of y, shell method 2 pi rh. Could you use this with this method? Yes. Have we done it with this method? Yes. But we're learning the shell method. Let's talk about the difference between them. So we have the point 1, 1, and 0, 0. All right, so in order to use the dy, that means my equations say x equals something in terms of y, right? So I'm just going to rewrite this to say x equals y, and I'm going to rewrite this to say x equals the square root of y, or y to the 1/2. Both are good. Now, as we did before, I'm going to draw a line from perpendicular to my line of rotation. This is my r, and my r is y because we're in terms of y for dy. The difference here is I have two functions here. So my height does not go, look at this red line. Normally my height goes all the way to the axis, but my height does not go all the way to the axis. My height only goes from the green line to the pink line. So that is my height. So we're going to say the height is x. Um, we could use x. Yeah, x2 or x1 minus x2, x2 minus x1, I don't care. Right minus left is the big thing. So the outside function here is the green one. So we're going to say y to the 1/2 minus the inside function is the pink one, y. So because I have two functions, my height actually subtracts the two functions there. My radius stays x or y unless I'm going around an outside line. So we're going to say the volume equals the integral. We're working in terms of y, so 0 to 1. Good news, it's the same bounds either way, right? So we have 2 pi, our radius is y, parentheses, and our height is y to the 1/2 minus y dy. Does that make sense? Before I move it, pause, think about it, talk to me if it does not. Okay, so we're going to say the integral from 0 to 1, I'm going to pull my 2 pi out front because I like it like that. Most of us do, right? We're going to say 2 pi. My writing utensil is not working right. Pause for a second. So 2 pi, the integral from 0 to 1. When I distribute, I get y to the 3/2 minus y squared dy. So we have 2 pi. When we integrate, y to the 3/2 becomes y to the 5/2 with a coefficient of 2/5 minus y to the 3rd with a coefficient of 1/3 from 0 to 1. So we have 2 pi. 1 to the any power is 1 minus 1/3 minus 0 plus 0. So I'm going to say 2 pi, common denominator is 15 because I really want to just do it on the screen today. So 3 times 2 is 6, and 5 times 1 is 5. So we get 2 pi times 1 over 15. So our answer is 2 pi over 15. Now, if you go back and look at it in the disk method, hopefully it's the same. It's supposed to be. Depends upon if I made a mistake. But what I want you to see is that here our height is equal to function 1 minus function 2. So if you're in terms of x, that'll be top minus bottom. And if you're in terms of y, that will be right minus left. The rules didn't change. The rules of top minus bottom and right minus left didn't change. We're just working with them a little differently in this method. I like these set up but do not integrate. Set up but do not integrate. Keep that in mind because you should not try to integrate. Well, yeah, you should not. So the problem says we're going to take y equals x to the third, y equals 8, and x equals 0, and we're going about the x-axis. So let's look at y equals x to the third. It looks like this. It is the tall graph. I like that one. Okay, I like math. So we have y equals x to the third. Our next equation is y equals 8. Remember that is a horizontal line, y equals 8. And our third equation is x equals 0. Now your shading, we're tempted to shade underneath the red line in some way, but we cannot because our shading has to touch all three areas. So here's our shading right here. Now we need to label that we're rotating about the x-axis. I'm going to hit this stuff for this in pink. The more you draw, the better this is. So we're going about the x-axis. So to do the shell method, we need to be in terms of y. The shell method means we need to use y because we're going around the x-axis and we're going to use 2 pi r h. Okay, so what we have here is since we're in terms of y, this means x equals something. Those are my functions. Anything that is y is a bound. So this y equals 8 is a bound. Here, I'm going to take my radius and I'm going to draw it down here and be perpendicular to my axis. So my radius automatically is y because we are in terms of y from this green circle over here on the right. So my radius is y, and this is going to be my height. So I recommend that you draw your radius from your axis up into the shading, and then draw the line from connecting either two functions or a function and an axis. Now I'm supposed to be in terms of dy. That means, like we stated down here, I need x equal to something. So I need my equations to be x equals, not y equals. So this equation right here that says y equals x to the third has to change. I need it to be x equals. Well, x equals, we're going to cube root both sides. So x equals the cube root of y. And let's call that y to the 1/3. I technically have two functions. My second function over here is x equals 0. So my height is going to be x1 minus x2. Remember right minus left. So my x1 is y to the 1/3 minus my x2 is 0. So that's y to the 1/3. So in this one, we have two different functions and we're going to subtract them to find the height. So this is a great problem to look at. So now we're going to say the volume equals the integral. We don't have a to b. We have 2 pi. Our radius is just y. And our height is actually y to the 1/3 minus 0, which is y to the 1/3 dy. That one's not very difficult to solve, so I don't know why they told us not to solve it, but we're not going to solve it because I said not to. Bounds. We need to talk about bounds. The 8 up here, do you see the 8 up at the top? See that 8 up at the top? That is the bound because y equals are bounds because x equals are your heights right here. And the other bound is 0. So your bounds are 0 to 8. Since this is not a bad problem, let's go ahead and do that one. I don't know why it says set up and not evaluate. I guess they're just saving you time in your homework. Let's go with the pink. So volume equals, I'm going to pull this 2 pi out front. We have 0 to 8. We have to multiply, but this gives me y to the 4/3. Add those exponents. So we have 2 pi parentheses. When you integrate y to the 4/3, you get y to the 7/3, and the coefficient is 3/7. 4/3 plus 3/3 is 7/3 from 0 to 8. So we have 2 pi parentheses. I'm going to pull this 3/7 out. I'm going to say 8 to the 7/3 minus 0. So this gives me 6/7 pi parentheses. 8 to the 7/3. The cube root of 8 is 2. And 2 to the 7th is, I believe, 128. I should check that, not be lazy. Hold on, let me go check that. Good news, it is 128. So 128 times 6 is 768 over 7 times pi. That is our volume for that area. I know it said set up and do not evaluate, but we broke the rules and did it anyway. It's all good. Okay, let's look at the next case. So the first case is our radius is x or y, and our height is our function. The second step is sometimes we subtract our heights. And now let's look at a third one. So when we rotate around an outside line, let's just say we have f of x here, and we're rotating it around a line out here, let's say y equals -2. Now, when you look at this f of x from a to b, and we're going to use the shell method because that's what we're looking at here. So this is y, and we're in the shell method, so that means we're going to work in terms of x, dx, shell method, 2 pi rh. So this could be done with the disk method, but we're practicing shell. So when I draw my radius, it has to be perpendicular to the line we're rotating around. This is our radius right here. And this is our height. Now our height is still f of x. It's still our function in terms of x. Because there's only one function here, so that's nice and easy. But our radius right here is still the length of x. That didn't change. But we don't stop at the axis line. We need to go all the way over here. So this has a length of 2. So we're going to have to add that length of 2. So our radius becomes x plus 2. Now I like this method better than the disk method because my outside line is always handled in the radius. Earlier we said the radius is x or y, and then later we said that later it would be plus or minus our outside line. This is where we are. This is the last step of what you're learning. So we're going to say the volume is the integral from a to b, 2 pi. Our radius now is x plus 2. It had a length of x right here to get to the axis, and then you have to add that 2 to get over to the line of rotation. So our outside line is always handled there, and then we have f of x dx. So when you have two functions, that gets handled in your height, h1 minus h2. When you have an outside line, not an axis for your line of rotation, that gets handled in your radius. So let's look at another problem. This one says set up but do not integrate. And it says y equals inverse sine of x. I'm not ever going to require you to use and know that. Y equals pi over 2, x equals 0, and you're going about the line y equals 3. So let's start with inverse sine of x. Oh, gracious. Inverse sine of x. So this is my graph for inverse sine of x. And then we have y equals pi over 2. Well, if you think about the fact that pi over 2 is the top of the first, the maximum there. So let's draw a line through there, not a dotted line. So this is y equals pi over 2. And then we have another line at x equals 0. I'm going to draw it in pink as well. Not a fan of that, but that's okay. And we're rotating around the line y equals 3. The line y equals 3 is almost at pi, so it's somewhere in here. Y equals 3. And this is the line we're rotating around. Now, when we rotate around that line, it is parallel to the x-axis. We are practicing the shell method. So in the shell method, we are parallel to x. So we do not want to use x. We'll use dy for the shell method for 2 pi rh. It's the other variable parallel to x, so we need to use the y variable. Now, here, this first green line says y equals inverse sine of x. And we need to solve this for x equals. Remember that dy means x equals f of y, right? Our function in terms of y. So we need to take this and solve for x. So we're going to, in order to solve for x, I don't know that students really think about this, but in order to solve for x, what you're really going to do is take the sine of both sides. So you take the sine of the inverse sine of x. So you get sine of y equals x. You're not dividing by sign. You're literally, like you would multiply 5 on both sides, you literally take the sine of both sides. We see that when we work in logarithms because we're used to taking the log of both sides or the natural log of both sides. So we took the sine of both sides. So our equation now is x equals sine y, and I would like to write it that way, x equals sine of y. So that's our green equation here. I wrote it in pink. That's a little weird. And we're rotating around that line. So let's put our radius right here. Now, this one's a weird radius because this is our radius, definitely. But the radius from here to here, from the blue line to the axis, would be 3. So in this case, we need to take 3. If we were to draw our radius down here would be just the variable. In this case, the variable is y. So this would, the piece from the blue all the way down to the green is 3, and we need to subtract out the y down here. So our radius is going to be 3 minus y. That takes a minute to think about. You got to think about it. Pause. 3 minus y. Now our height is not too bad because our height is just going to be that equation, sine of y. So we're going to say volume equals the integral from a to b. Let's come back to the a to b. And we have 2 pi. Our radius is 3 minus y. And our height is sine of y dy. Now our bounds are in terms of y, so they're going to go from 0 to, this is the bound because it's y equals. So your bounds are going to be 0 to pi over 2. Yeah, we don't really want to integrate that. It requires the integration by parts. We haven't learned it yet. So it definitely is a setup but do not solve. Okay, let's look at another setup but do not solve. You have to get used to the whether you add or subtract. Normally, when you cross the axis, you're going to add. When you don't cross an axis, you're going to subtract. And often it's the outside line minus the variable. So that's a helpful hint there. This one says set up but do not integrate, and it says y equals 4x minus x squared, y equals x, and we're going about x equals 7. So 4x minus x squared is an upside down parabola. The minus x squared tells me I have an upside down parabola. And if I set those equal to 0 and factor, I get 0 equals 4x minus x squared. 0 equals x parentheses 4 minus x. So x equals 0 and 4. Those are my intercepts. So that helps me label my upside down parabola. So we go from 0 to 4. And then we have a line y equals x. Well, if I put 1 into the y equals x, I get 1. And if I put 1 into the other one, I get a point. If I look at the graph, it's going to look like this. Not drawn to scale. How about that? Oh, not green. I'm going to just draw it over it. So it's not drawn to scale and it's not green. Here's pink. Okay. So this one is y equals x. And this one, the green one, is y equals 4x minus x squared. And we're rotating around the line x equals 7. The line x equals 7 is a horizontal line, 4, 5, 6, 7, over here somewhere. So this is x equals 7, and we're rotating around this line. Now we're parallel to y, and we're practicing the shell method. So we're parallel to y, so we want to work in terms of x, 2 pi r h. Well, that's good because our bounds are automatically 0 to 4. But let's talk about this radius. Our shaded region is going to be this small piece between the two curves. That is very small. I generally like to zoom in, but I didn't do a good job with that. So I apologize for that. Let's look at my radius is going to go from the center of this value all the way over to here. Now this is another one of those subtraction ones because we didn't cross the axis. This is our height right here. This is our radius right here. Now our radius, I would like for you to think, let me see if I can find a better color. We're gonna have to go with yellow, and I'm not a big fan of yellow, but we're gonna do it. So our radius from this line all the way over to the axis, this radius is 7. And normally this radius right here from the from our height over to the axis is the letter x because we're in terms of x. So we want to subtract that part out because we want to keep this bluish color, red. Let's make this red. Do you see this red radius right here? So we want to keep the red radius. So that radius becomes 7 minus x. It's the whole length. I wish you could see me, but it's the whole length. And we're subtracting out that little x on the far left. Now the height's not too bad. So the height is going to be the top minus the bottom because we are working in terms of x. And the top is the green line, which is 4x minus x squared. And the bottom is the pink line, x. So that means my height is really 4x minus x is 3x minus x squared. So that's our height. So here we have our height. And way over here we have our radius. So now we can say the volume equals the integral from a to b. We're working in terms of x, so that's 0 to 4, 2 pi. Our radius is 7 minus x, and our height is 3x minus x squared, all with respect to x. Now that one's not too hard to work out. I think they just wanted you to practice setting it up, and then they're going to have you work it out somewhere else. Oh yeah, it's a different problem later down. So you would do FOIL, and then you would evaluate. Let's go ahead and do it. So the volume equals the integral from 0 to 4, 2 pi. We're going to do FOIL here. And I'm going to waste an extra step because it's too late for me to be doing it in my head. So I get 21x minus 7x squared minus 3x squared plus x to the third with respect to x. And to pull out my 2 pi and choose to combine like terms. So I'm going to say 21x minus 10x squared plus x to the third with respect to x. So we have 2 pi. When we integrate, we get 21 over 2x squared, 21 over 2x squared minus 10 over 3x to the third plus 1/4 x to the fourth from 0 to 4. So let's keep the 2 pi. 4 squared is 16, divided by 2 is 8, times 21 is 168, minus 4 to the third is 64, times 10 thirds is 640 over 3, plus 4 to the fourth divided by 4 is 4 to the thirds, which is 64, minus 0. You can totally use a calculator to do that part. So I have 2 pi times 56 over 3, which gives me 112 over 3 pi. Let's go back and make those notes one more time. So when we're in the shell method, the volume equals the integral from a to b of 2 pi rh dr. So the radius is x or y plus or minus an outside line. Your h is going to be f of x or f of y. If you have if there are two functions, then h equals f1 minus f2, top minus bottom or right minus left. Let's see, we're going to be in terms of the other variable. So if you're going parallel to y, you're going to work in terms of x. If you're going around the x-axis, you're going to work in terms of y. And I think that handles everything you need for your shell method. 2 pi r h d r. I hope it makes sense, and I hope you have a great day. Thanks.